So in this video we're going to calculate the Taylor polynomial for the function natural log of x plus 1 at the point 1 and for 5 terms. So we have our generic formula here for the Taylor polynomial, which is here, which is Tn of x equals f of a, which is the value of the function at point a. Well, in our case a is 1 and n is 5, so t5 of x equals the value of the function at 1. Then we've got these here, which is the first derivative divided by 1 factorial and x minus a to the power of 1. Well, a is 1, so that's the first derivative at 1 over 1 factorial x minus 1 to the power of 1, which is just x minus 1. Then we have the second derivative at 1 divided by 2 factorial and x minus 1 squared, and then so on. So we've got the third derivative, 3 factorial x minus 1 cubed. And all these a's will all be 1 because that's the point which we're interested in. So you'll see there's a pattern here. So the second derivative, you've got the second derivative, 2 factorial x minus 1 squared. For the third one, you've got third derivative, 3 factorial x minus 1 cubed, and so on. So the 4 in this one will be a line there, and the 5's there and there. Okay, so now we're going to calculate all the derivatives of our function ln of x plus 1. So we're going to differentiate the function ln of x plus 1 5 times and the value of each derivative at 1. Okay, so here's all our derivatives. So the function ln of x plus 1, so we'll calculate that at 1. So that's going to be ln of x plus 1, which is basically ln of 2. And ln of 2 is a very long digital decimal number. Which goes on for a long time, so we just leave that as ln of 2. There's no need to worry about that, just leave that at that. Then we take the derivative of ln of x plus 1. Well, when you take the derivative of a natural log of anything, you take the reciprocal of what's inside the brackets here, so it'd be 1 over x plus 1, and then multiply it by the derivative of what's inside. So the derivative of x plus 1 is just 1. So basically each time it's going to multiply by 1, so we won't really need to worry about the chain rule on this occasion. So it's just 1 over x plus 1. Then that's the first derivative. And then the value of that at point 1 is basically 1 over 1 plus 1, which is a half. So the first derivative is equal to a half. Then we differentiate 1 over x plus 1 again. And then we could imagine here x plus 1 has got a little 1 here at the side here. So 1 times 1. And because the 1 at the bottom is a minus, it would be minus 1. And then increase the power by 1. So you can see here 1 times minus 1 will give us the minus 1 on the top, on the numerator. And then this 1 here will just increase by 1 as you do when you differentiate. And that then becomes 2. So minus 1 over x plus 1 squared. And then we plug in the value of 1. So minus 1 over 2 squared. 2 squared is 4. Minus 1 divided by 4 is minus a quarter. So that's that one. Third derivative, again, minus 1, this here is actually a minus 2. So minus 1 times minus 2 is plus 2. So that gives us our plus 2. And then increase the power by 1, and that gives us to 3. Then plug in the 1 for the function here. So 2 cubed is 8. 2 divided by 8 is a quarter. So that's how we get a quarter. That's good there. And then the same again. This 3 will be a minus 3. 2 times minus 3 is minus 6. Minus 6 over x plus 1 with an increased power of 4. So as we know, x plus 1 is 2. 2 to the power of 4 is 16. Minus 6 divided by 16 is just minus 3 over 8. Same again with the fifth derivative. Minus 6 times minus 4 is plus 24. Increase the power by 1. 24 over x plus 1 to the power of 5. X plus 1 to the power of 5, well, 2 to the power of 5 is 32. 24 divided by 32 gives us 3/4. So that's the value of all our derivatives. So now we can go ahead and just put all these into our Taylor polynomial. So t5 of x equals f of 1 plus the first derivative at point 1, x minus 1. So I've written this out like this rather than do it all in one go. So it makes it nice and easy for you. So then that's your first stage there. Then you know what you're dealing with there, just by putting all that down there. Rather than rush it all in one go, you can make silly mistakes. So you say, for example, here f5 1 divided by 5 factorial you've got f5, the fifth derivative at 0.1 is 3/4, so you just put 3/4 on the top there, divided by 5 factorial, which is 1 times 2 times 3 times 4 times 5, which is 120. And then x minus a is just x minus 1 to the power of 5. And same with the fourth derivative, you've got minus 3/8, so you just put minus 3/8 and 4 factorial, 1 times 2 times 3 times 4, which is 24. Okay, so let's put these numbers in and see where we arrive at. So the function f of 1 we knew was ln of 2, and we knew that the first derivative was valued at 1, so let's just have a look up here. There we go, first derivative 1, 2 on the bottom, so there's the 1/2, so we've got 1 and a 2, and then times it by 1 factorial, x times x minus 1, so that's taken care of. Second derivative is minus 1/4, so we've got minus 1/4 times 2 factorial, x minus 1 squared. Same again, third derivative is 1/4, that's where we get this one here, so 1/4 times 3 factorial. So you see what's happening here, look, you see the third derivative at 1, which we calculated here, was 1/4 divided by 3 factorial. So that's how we put the 3 factorial there, and x minus 1 cubed. Now the fourth derivative, minus 3/8, so that's minus 3/8 times 4 factorial. So you see here's our little formula here, f(1), 4 factorial, so 4 factorial is 24, so minus 3/8 times, that will be 24, x minus 1 to the 4. And then the fifth derivative is 3/4, so that's where we put the 3/4, and then times it by 5 factorial in the denominator, x minus 1 to the 5th. And now we can simplify all these up. So 1 over 2 times 1 factorial is just 1/2 times x minus 1, so that just gives us x minus 1 over 2. Don't forget your ln of 2 at the beginning there. So ln of 2 plus, because that stays as a plus, x minus 1 over 2. You could write 1/2 times x minus 1, but it's just nice and neat to write it like this. And then we've got 4 times 2 factorial, that's 4 times 2 is 8, so that would be minus 1/8 times x minus 1 squared. Well, it's just change this plus sign to a minus, and then x minus 1 squared in the numerator, and leave the 8 on the bottom. That would be the equivalent to timesing it by minus 1/8 x minus 1 squared. Third term, x minus 1 cubed, so that's where we get this minus 1 cubed. And then 3 factorial is 6. 6 fours are 24, so we just leave the 24 in the denominator. Fourth term, x minus 1 to the 4 over 64, to see where we get that from. 4 factorial, that's 24. So if you add 24 times 8, you get 192. 192 divided by 3 is 64, but it's a minus, so don't forget to change to a minus sign here. So that's x minus 1 to the 4 over 64. And the last one demands a little bit more mental arithmetic going on, or you could just put it into your calculator. 5 factorial is 120. 120 times 4 is 480. 480 divided by 3 is 160. It's x minus 1 to the 5. So you've got x minus 1 to the 5 over 160. So this here is our answer. That's our 5-degree polynomial for ln of x plus 1 at the point 1. So let's put this into a graph and see how accurate it is. So the thick black line, that's our Taylor polynomial. And as you can see, it does touch the dotted line, and the dotted line is the function of ln of x plus 1. So that's pretty accurate. We was asked to calculate it at point 1, which is here. That's point 1. As you can see, it's pretty accurate all the way up to and just past 2. So it's only when it gets to about 2.5 to 3 that it starts to separate away and go off in a different direction. And the same when it gets past 0, it approaches minus 1, and then it goes off to a different direction as well. So it's pretty close all the way along. So we could say that's a pretty successful result. Okay, just to go and show you again, T5x equals ln of 2 plus x minus 1 over 2 minus x minus 1 squared over 8 plus x minus 1 cubed over 24 minus x minus 1 to the 4 over 64 plus x minus 1 to the 5 over 160. And that completes it. Thanks for watching.